Thank you, Risto, for the introduction. So, my name is Tuomas Keränen, and I work as a product manager at Efficode. I'm responsible for the Efficode Root DevOps platform offering. And I'm very happy to be here in Amsterdam today. It's nice to see so many faces here. You can imagine this is a big day for us at Efficode. So my plan is to use this slot for talking about DevOps platforms, Efficode Root specifically, but also centralized DevOps platforms in general. So what are they for? And once you start taking one into use, which are the steps to follow that you can do it in a coordinated way without creating a mess? And I'm basing this presentation on the experience we've gathered during the past 10 years as we've been building these solutions to our clients, like Risto explained. So still a bit more further detail about Efficode, especially the DevOps part. So we, like Risto said, we've been doing this as the DevOps consultancy business. We've been involved in that since 2007. Currently, if you look at the situation today, we have over 100 DevOps projects in progress as we speak today. We have a bit more than 130 DevOps consultants working for us as engineers, support and maintenance personnel, and so forth. And Efficode Root platform, as I'm presenting it today, in that shape and form, has been around since 2014 roughly. And currently, if you calculate or count all the customer-specific platform instances together, we have around 15,000 users for the platform. A small peek to our customer base today. So I'll give you a couple of examples here. So OP Financial Group is one of our first clients, also one of the biggest ones we have today. They are one of the largest financial institutions in Finland. They have roughly 12,000 employees, 1.4 million customers. And they are also now expanding to areas outside of traditional banking and insurance businesses, to health and mobility as a service businesses, just to name a few. They've been our customer early on, starting from 2014. They have a large number of outsourced activities, in addition to a fast-growing volume of internal development. And despite of this, despite of having multiple suppliers working on specific projects for them, they have established an OP way of creating software. And they've done it based on the platform that we provided them with. So they have a turnkey platform solution from us and with a really low barrier to start new activities on top of it. It's also highly scalable because the number of users in the case of OP is quite big. Then another one, this is DNA, one of the telco operators in Finland. There are altogether 3 of them. They have 3.9 million active subscriptions, both fixed and mobile. We built them an on-premise DevOps platform, and it's managed and hosted, not hosted, but managed and maintained by us. And they've told us, and it's actually you can go to our website and see the guys. I mean, telling these facts to you. So along the years, they've saved millions, tens of millions, because of faster and more frequent product launches that they've been able to make on top of the DevOps platform. So these are just examples. Of course, we have plenty of other customers as well. Also outside of telco and finance sectors, we have gaming industry clients. We have clients on the heavy industry side going through the digital transformation and so forth. We are pretty much kind of covering the whole sort of a big spectrum of sectors with our current installations. So this is more or less what we provide to our clients today. This is our reference architecture. It is a starting point for an actual customer-specific platform design. Like you see, we have chosen certain tools to be part of the reference architecture, but the platform itself is highly flexible. So let's say that one of our clients would like to switch a certain element here with an alternative tool. It's completely doable, and we do it often. So you could say that no two instances are completely alike in typical case. By a DevOps platform here, we mean a complete, highly automated software assembly line. And it covers everything from required management all the way to automated deployments. Some people talk about software factory. That's one simple way to put it. And even though the DevOps platform, having these tools available, doesn't as such make you DevOps capable, this sort of a platform creates a foundation for everything else, such as the cultural change that is required as well, in case while you are transferring from more traditional agile way of working to DevOps way of working. So this is the platform, as this is meant to be a shared platform, which means that once you start using this, you no longer have project-specific, sometimes throwaway assembly lines that you set up in the beginning of the project and then tear down when they are no longer needed. So this is to be used by both internal projects that you're running as well as anything that the suppliers will do for you. So how do you take a shared platform like this into use without creating a mess? So we have a few recommendations here based on our experience. One of them is that you should take one or two pilot projects and go deep. I mean, implement the project by using all these tools available as part of the platform. But for the rest of the portfolio, you should maybe choose a phased approach, a stepwise approach that is a bit safer. So what is this stepwise approach then? So the first point here is that you should start building organizational robustness based on the platform. We will start eliminating single points of failure in the system. Those might be people, those might be technologies that you've chosen. So you should remember that information when you are talking about a certain software project, for example, all critical information related to that project belongs to the team that is implementing the software, not to individuals inside the team. All the critical project information that you have should be contained by the platform. That's the rule of thumb here. Then you need to control change, which means that you always have up-to-date visibility to the system state. And this then enables efficient problem tracing if you run into trouble, and then quick rollbacks if you need to go back to a previous state in case of failure. Then the rule here is that you shouldn't do any code changes directly to any of the runtime environments that you have. Everything should always go through version control. Basically, this means that all project requirements, all the quality criteria that you have, task descriptions, bugs, incident reports, all those should be in the project management and ticketing systems available there. Then all the project deliverables, all the code, meaning, of course, the application code, but also test code, environment definitions, environment configurations, and so forth. Those should be in the version control. And then everything that comes out at the end of the pipeline, the installable packages, those should be available in the binary storage. And if this is done, surprisingly little amount of critical project-related documentation needs to be authored separately. All the critical information that you have is already contained by the platform while you are running it. Of course, you still need to do architecture documents, you need to write customer documentation and so forth, but all the critical elements that tell you about the project itself, its state, requirements, all that is always available in the platform. It's in nobody's mind, it's always documented in the platform. Then one final point about the communications. So when you want to have a robust organization, you want to have transparency there, so that people are aware of things. People stay aware of things. You need to start slow. You need to start moving from slow, exclusive communications that happen over email, for example, to fast and inclusive communication methods like Slack or Flowdoc and so forth, that allow people to join and leave these discussion groups as they wish. So when I'm sending an email to somebody, while I do that, I need to choose the people I talk to, basically. And then one of them may forward these messages further to a bigger group of people, or they may not. But anyways, it's exclusive. It's my decision to decide which names I input to the message to field. But if you are using these inclusive communication mechanisms, the information will be distributed around far more efficiently. All right, so from the tooling perspective, this is what you need. So you need the requirement and project management functionality. You need the version control. Everything begins from there. So if you make a change to the code, then a build will follow. Then the testing will be done, and everything based on the test cases stored in the version control, and then you have the output stored in the binary storage. We call them sources of truth. So if something is not here, contained by the platform, it doesn't exist. If it's here, documented in the system, it exists. It's as simple as that. And then for all the other documentation that you may have, you have the separate document management database, obviously. Right, so the second step here in this process, kind of a simplified process, but process still, is to enable high throughput. And with high throughput, I mean here that you are able to deliver value to your end customers faster than before. Deliver features, if you're talking about a software application. So you should aim at having predictable short release cycles. The agility that you may have in the development team should expand to quality assurance as well as operations. And you should release small and release often. I guess that is the rule of thumb if you're following the DevOps practices. Then you should enable short feedback cycles. So the developer should get the quality feedback in minutes instead of hours or days. And if you have made a change to the system and you have committed that change to the version control, and the testing process, automated testing process begins from there, you should get the feedback back in 5 minutes. You take a cup of coffee and you know whether the change that you made was successful or not from the testing perspective. And this can be achieved by high level of automation. So if you have less manual work, you have less hand time people spend on working on the testing side, you have better throughput basically. So and when you start increasing the ratio of automated testing against manual testing, the first target, easy target would be to cut the time spent and the resources used in manual acceptance testing by 50%. And this is completely a realistic target. Of course, some manual testing will be required, but quite a bit of it can be automated early on. And then on the environment side, the point here is that you would have on-demand test and development environments. So you spin them up when you need them, and you turn them down when they are no longer required. And this can be done quite efficiently with public cloud services like AWS, Azure, and so forth. So if you need to spend days waiting for somebody to set up a server for you, you're not very agile. It will impact your throughput in a negative way. Right, okay, so again, coming back to this architecture here, so this is what you need for automation. You need the CI/CD pipeline, version control, automated testing tools, and automated deployment tools. And then, of course, the infrastructure here needs to be defined as code, so you can easily spin up new environments on demand. Right. Okay, now you have a system, you have a robust organization, all the information is contained by the platform, and you are able to deliver through the pipeline with certain efficiency. So what would be a logical next step? It would be to create visibility across the pipeline. So you need to get visibility to the adoption of these methodologies in the projects that you are running. This is a feature that is actually requested by one of our customers, and we build it for them. So you can have a up-to-date view to the way that the teams are using the platform tools. Are they using them at all? If not, you need to go and ask that why aren't you using automation, for example? or if they're using them, are they using them frequently enough? That sort of signals that they are going to the right direction. Then you should demand up-to-date quality information. So if the quality reports that you receive are done by hand, it means that you are reading historical data. If the process otherwise works with DevOps speed. So you need to get this quality information real time from the system. Then you should start measuring project performance, like throughput. How many features do you get through the pipeline in a certain time frame? And you should also start identifying bottlenecks. So are there certain stages in your software assembly line that take more time to complete than others? So, and if you notice those, you should get rid of those bottlenecks if possible, by adding automation or using other methods available. Then once you have this data available for a large portfolio of projects, you can start identifying benchmarks. If you have teams that perform really well, you need to go there and take a look. Okay, what are you guys doing right? Because the quality is good, your throughput is good, you don't have bottlenecks, things simply work. You go there, you pick you sort of talk to the people, you identify the things that they are doing right, and then you start distributing these same methods across the organization. So the idea of having these metrics available is not to give you like stones that you can throw at the project guys when they are failing to do things like they should. It's more like for identifying the positive benchmarks, people who are using the platforms in the correct way, and then you distribute that information. So that's the kind of a value-adding way to kind of use the data correctly. And then gradually, once you have enough data available and you've collected historical data about the project performance, you are able to start sort of doing predictive analysis. So if you look at the metrics, does it look like that the project is going to be completed on schedule? For example, is it going to meet the quality targets that we've set? You start getting these ideas. And this is also an opportunity for like AI and machine learning. So we can use machine learning to identify the activities that are possibly going to be derailed for some reason early on, so that you can still affect the output. So what you need to have here is, of course, the analytics and monitoring part. And the data is collected from all these tools that are part of the pipeline. So you collect data from all these tools, and then you combine the data to dashboards, to dashboard views that you're able to look at. And we have some of them built into the product itself, to the service itself. So we have here, these are just the examples. The small font. I'm not going to go to the details, but we have a view for management. You're able to see the performance related data related to the projects. There is another view for quality assurance. There is a view for development. There is another view for operations, which is missing from here. There is a view that allows you to track the tool usage. Are these guys adopting the methodologies or not? And if I, as a developer, do something here, since these metrics are obviously shared between the teams, if I make changes here, I'm able to see the effect of these changes on the quality dashboard as well as in the performance dashboard. So that's the idea. So you'll have a common set of metrics available for all the team members: devs, quality assurance people, operations people, management, and so forth. Right. So then I'm looping back to some of our clients like OP, the financial company I mentioned in the beginning. So since they have plenty of outsourced activities, they need better visibility to be in a position that they can control what the suppliers suppliers are doing. And this is one of the key reasons why they chose to build a centralized platform. It has many benefits. So, for example, if you're using a centralized platform and the suppliers are using it as they should, all the IPR that they are developing for you with your money will stay with you. It'll be stored in a safe place. All the source code will be in your version control system. All the project deliverables will be in your binary management system. This platform, central platform, once it's available, it's always up and running. So when you start a new project, you don't have to start the project by setting up a new production line. The production line is already there. You just have to take it into use. So this saves a lot of time and money. And then once you have all the suppliers using the same platforms, producing the same metrics, you are able to compare how well they sort of take advantage of the advanced functionalities that you might have there. You're able to compare the suppliers against one another. Then the vendor lock-in will be reduced as well, because if you're changing a vendor, it becomes a matter of changing something in the access management system instead of going through a series of migrations from platform to another. So that's the reason why in this platform I think we have this key element of access control, so that you are able to. There's a centralized place where you control access to the platform as a whole. So you don't have to go to individual tools to control access to them. You do it in a central place here. So if somebody joins a project, you give him access to the project once from here, and then all the assets through the project-related assets through the pipeline become available for him or her. And then if you have multiple suppliers, they are isolated from one another. So if I'm one supplier A, I'm working on my project, I have no idea what supplier B is doing, if that's what the platform owner in a way desires. Then a couple of words still about clear roles and responsibilities. So the idea with this platform is that one key idea here is the self-service principle. So each project is responsible for its own efficiency, and they carry the main responsibility. The people using the tools, they carry the responsibility. But for this common platform approach to work, the platform needs to be properly maintained and supported. And the projects will need support, especially in the beginning, in the onboarding phase, when they start using these tools. If this maintenance part is completely neglected, the platform will gradually break and become unsecure. Because if you don't have a dedicated team who's looking after these tools and the tool chain and the assembly line, it will mean that you will miss security updates or performance enhancing updates. And gradually the system will break. Those support and maintenance resources, they can be internal or external or combination of the above, but you'll need people who look after these tools as their main job. All right, so that was more or less what I was planning to say, but still as a summary. So when you're going through a DevOps transformation, correct tool usage is key here. And if you do something, at least you should sort of enable or create these single sources of truth in the system. You should enable end-to-end agility for high throughput, and then you should have a way to see what is actually happening in the pipeline by looking through metrics instead of talking to people. And if you have this platform and it is centralized, it provides many benefits over having like multiple independent platforms or assembly lines running in parallel. And then you should plan carefully where to focus your own resources and what to buy from outside. So do you want to spend time making sure that the platform works and is available, or do you want to spend your time in making sure that the platform is used in the most efficient way? It's your choice. All right, that's what I had to say. So thank you.